It is part 2 of section 8.8. The second type of improper integrals is with integrands of infinite discontinuities. So let's see these cases. Here, f of x is continuous on a to b except the beginning point, and is discontinuous at the one point. That one is describing the case where the function value goes to infinity at point A. Okay, let's see the picture. That is now from A to B. Now, function value is approaching infinity around A, like that. Then we consider from C some point, so that in this area now the function value is bounded, finite, so that we can get integral as usual. And then we try to take a limit as C approaches A from the right side. So that is exactly this term same. And also for here, the function is continuous except the last point. And now at the last point, the value goes to infinity. Then now we do the similarly in this way. We try to get integral from A to C, and we take a limit as C approaches B from the left-hand side. Okay. Now, another case is just the function has a discontinuity at a point inside the interval. So for example, here the A to B is given, but at point, and the C here now, at point, here function value go to infinity, and the other side also can go minus infinity. But anyway, let's try to make it this way. So that once it is happening, then you have to consider the integral part by part from A to C, and now from C to B. For each one, if the limit exists, then we say that the integral is convergent. And so in this case, you have to have the limit for both of them. In each case, if the limit exists and is finite, then we say the improper integral converges, and that the limit is the value of the improper integral. If the limit doesn't exist, the integral diverges. Okay, let's try to solve some examples. Determine whether the integral converges or diverges. Evaluate if it converges. Okay. Now, as x approaches 0, this integrand blows up, so that here, for this integral, we have to get in this way, limit. Now, C approaches 0 from right side, and then integral from C to 32, and 1 over, okay, let's write down this one, in this x to the minus 1 over 5 power, and dx. Right? Okay, for this one, now antiderivative is here, okay, what is that? And plus 1, that is 4 over 5, and its reciprocal is 5 over 4. And then here, x to the here 4 over 5. Right? And then we are evaluating here from C to 32. So that is same as limit, same limit, and then 5 over 4. And here, that is now when x is 32, that is 16, and minus, and C to the 4 over 5. Right? Now, once C is approaching 0, then it is approaching 0, so that the value is now becoming this product, which is same as 20, right? So it is convergent and limit is 20. That's the final answer. Okay, same question along with this one. Now, at 0, tangent x has value 0, but at pi over 2, the function value is blowing up. So that, okay, this can be written in this way. Limit, now c approaches pi over 2, and integral from 0 to c, and tangent over x and dx. Okay, so its antiderivative is minus logarithm and cosine x, right? Okay, and because tangent x is a sine x over cosine x, so there is a logarithm cosine x, we have to put here the absolute sign. Okay, we are evaluating now from 0 to c. Right? Okay, now for that one, so the same limit, and then once you are evaluating at 0, along with this negation, then that is cosine 0, which is 1, so that now that is 0. And then minus here, once, okay, let's see in this way, that is now your logarithm of cosine of c, right? Okay, now c is approaching pi over 2, then that one is approaching now 0. Then this whole thing is approaching minus infinity. So that is converging to minus infinity, so that here the final answer must be infinity. It's not convergent. Okay. Okay, same kind of problem, but here when x is half and x is 2, no problem. However, once x is 1, then the logarithm 1 will make a 0. Okay, so that the problem happens when x is 1. So we have to separate out. Okay, the integral can be separated. Now the first portion is from half to 1, and second portion is now from 1 to 2, and integrand is 1 over x logarithm x and dx. Okay, now let's consider the part by part. Okay, first we consider this part 1, that's now part 2. Okay, for part 1, that is same as here. Okay, at 1, the value will become 0 on the bottom, so that we have to consider this one in this limit, and now c is approaching 1, of course, from the left hand side. Now that is integral half to c and 1 over x logarithm over x dx. Okay, the same limit, and then the antiderivative of that one is same as a logarithm and absolute value of now logarithm over x, right? Okay, so its derivative will become on the bottom logarithm x and derivative of logarithm x 1 over x. Okay, so we reach that one. Okay, so here we are evaluating from half to here c. So that is now, so that same as this one, so limit, the same limit, c is approaching to 1, and then that is here logarithm of logarithm c, and then minus, and this half, then there's a logarithm and logarithm of a half, right? Okay, now this is a bounded number, and that one, as c approaches 1, this one is approaching to now 0, then now this whole thing is approaching to minus infinity. So a part is approaching minus infinity, so that here the limit doesn't exist. Okay, we don't have to get the second part. However, for this problem, if we are missing the fact that at 1, this is not defined, it's discontinuous, so that if you try to get integral for that one, and without considering this part, then, okay, that's the wrong one anyway. From given integral, if you are trying to get antiderivative, then that is same as a logarithm, absolute value of logarithm of x, and here you are evaluating from and half to 2. Okay, now for that one, here once it's 2, then there is a logarithm of logarithm 2, and then minus and half, then there is a logarithm of absolute value of logarithm and half, right? But this one is the same as minus logarithm 2, along with this absolute sign. These two will become the same, so that it must be 0. Right now, apparently, left of, okay, the interval is given here now. Okay, somehow this, okay, tablet has a little bit of some problem right now. Okay, is given here from half to and now 2 and around 1 now here. Okay, the value will go to minus infinity and here now, and then over there it goes to plus infinity, so that if you consider whole thing, then it can be cancelled out to become 0. But in this case, the limit doesn't exist. Part by part, you have to have limit. But for each part, there is no limit, so that it is divergent. It's wrong one. If you solve this problem in this way, then it's a wrong answer. Okay? That's the end of second part. Thank you.